by the time you have it on.
Well, good afternoon, ladies and gentlemen. It's nice to have you here on such a rainy day. Thank you for coming. It's our pleasure and my honor this afternoon to introduce Dr. Mark Dean, who is an IBM Fellow and currently is the Vice President of IBM's Almaden Research Center. At the Research Center, he oversees about 400 scientists and engineers working on a wide variety of topics. The list is far too long for me to mention here. Let me just say a couple of words about Dr. Dean, who I've had the pleasure of meeting with a couple of times now. He's been with IBM for his entire career, which is more than 25 years in the information technology business. He has contributed to the design of a wide range of IBM computers, starting from PCs to Blue Gene most recently. He's been involved in designing information technology systems and doing research in a variety of areas. I was pleased to see that he's a member of the American Academy of Arts and Science. I'd like to have a private discussion about the movies that he's made, how that came about, and also the National Academy of Engineering, and has been inducted into the National Inventors Hall of Fame. This afternoon, Dr. Dean will be talking about opportunities for innovation in the IT industry. I've gotten his permission to invite you to interrupt at any time with questions. This should be an interactive. We have a small group here. In fact, if you'd like to move down closer so that you can get his attention more easily, make this highly interactive, ask questions, raise debate issues. I think it's to be that kind of an afternoon. So with that brief introduction,
thank
Mark,
you.
Thank you very much for coming.
Thank you.
Good to have you here.
Hi, good afternoon. This is true. I'd rather things to be more interactive than me just presenting. And I can talk about anything where I know anything about it or not. At least that's what my wife says. So I'm quite open to discussing anything that you're interested in discussing. I've got some charts that talk to the fact that this is a great time in our industry. It's actually a great time for people to be graduating from college because there's a lot of opportunity to change how we do things, because there's a lot of things that need to be changed right now. I'm going to hit on a few that I'll show you, and please do ask questions, because it gets boring if I'm just up here talking, to be honest. I get bored, you'll get bored, and so it'd be much better to be more interactive. So let me start. I think I'm going to leave a little time at the end as well, but we've got to, what, 5?
We have to 5.
Okay, so I'll get through this. IBM's been on a pretty big campaign around innovation. And we really are putting a lot of focus on innovation broadly. Collaborative innovation, multidisciplinary innovation, innovation that matters. And one of the key focus areas for the IBM culture is to be an innovation company. And Nick D'Onofrio, our Executive Vice President, does a lot of these kinds of talks, and he really provides a significant emphasis on this. And we in Almaden provide a significant emphasis on this. And the keys for our efforts is that it is open, that it is multidisciplinary, because we believe that's where the biggest opportunities are, is working across disciplines. I call it the white space. So if you innovate in the white space and connect across disciplines, that's where the biggest gain will be. And I'll put a lot of emphasis on working across disciplines, working across functions, working across science areas, because that's really going to be a lot of opportunity there. Obviously, there's, for us, and I think in general, there's innovation in a product, innovation in business models, and innovation in the area of services. So we as a business have to make this happen. We, in support of our customers, have to make this happen. And I think if we can make innovations occur in these 3 different areas, then it will differentiate us from the rest of the industry, and that'll be key. You can see that the industry used to focus on invention, proprietary work, patented, and it's ours, and then we differentiate because we own this special stuff. It's important, though, we've learned, going all the way back to the PC days, that letting other people play in the in the industry, helping other people participate in grabbing at the opportunity grows the total market. And so innovating in the open space, innovating to let other people play can be key, and is key in most cases, right? And there's many, many examples of innovation that allows other people to participate, thus growing the market bigger. And usually those are the winners. Ethernet versus token ring is an example of that. The IBM PC versus Apple computer, even though Apple was a better machine, the PC won because other people could play. And there are many, many examples of that. And I would say that's where my bias is, and right now that's where IBM is focused. In standards, open design, working with collaborative with other vendors, other people. I think that's going to be key for our success and for the industry to move forward. This shows a little bit about how we are innovating in the present time and where we came from, where we used to focus on invention. And there's a couple of points here. The one I'll continue to repeat is multidisciplinary. And that's why I would tell you the schools that tend to embrace cross-disciplinary type of research and coursework, curriculum, I think will enable their students to be more successful than people that tend to just be siloed. And it's hard to break out of those silos, but really that's where a lot of the insight can come from. The other thing I would point out is that innovation needs to be responsive. We need to be responsive to the needs. It's always good to innovate in context. If there's a problem to be solved, it's always good to solve that problem. You'll get much more attention than just exploring, trying to find, if you have an answer but you're trying to find a question, that's a little bit harder. If you have a question that you can solve, it usually tends to work a little bit better. I put this chart in because IBM Research has gone through some transitions. Usually about every decade we kind of adjust. And one of the reasons we have, I feel, been successful versus other peer research groups is we've tended to adjust to the needs of the IBM corporation, and we tend to try to find new ways to innovate. Today we're innovating a lot in the customer shop. We're actually helping customers be successful. How do we bring technology to bear to help customers be more successful? With their success, we'll draw our success. And so we've got some programs put in place with that kind of focus, and it plays to our strengths. So this is my favorite chart, and this is why it's such a great time to be in our industry, because there's a lot of stuff that we've been doing for years. Even before most of you guys were even born, we were doing things a particular way, and it's time to rethink how we do things. It's time. The way we've been doing is getting old. And it's like vacuum tubes and VCRs and cassette tapes. And it's time to kind of try a new approach because the world has changed. Right? The world is driven by information, by data. It's not necessarily driven by needing more compute capability, although that's great. I mean, we should keep that. But we've got more data than we know what to do with, and maybe we need to now tailor our design points, our software, our services, our hardware to be focused more on data than to be focused more on compute. It's different, but maybe we need to be more distributed than centralized. And so I'm going to hit on some of the prospects of this just to see if it's true. Can we live the way we have for the past 40 years, 50 years if you count the life of computer science, and or do we need to change? Do we need to move forward? Do we need to take a new look at programming? Do we need to take a new look at how we store information? Is CMOS, will it live forever? What do we need to worry about there? Search, email, just simple stuff. It's potentially time to do things a little bit differently, and we'll see. So we have a bit of room to go with CMOS, a little bit. Not a whole lot. Where we are in the lifetime of CMOS is interesting because if we look at where we were at the same time relative to bipolar, we knew what we could use to replace bipolar. In fact, when we had vacuum tubes, we knew what we could use to replace vacuum tubes. We don't know exactly what we can use to replace CMOS. All right? And we really do need to identify what will come beyond CMOS. Because if we don't, we're going to run out. I mean, the CMOS is great, but there's very little room left for us. Now, we've got 10 years of innovation that we'll keep CMOS going, but it's starting to get scary. Right? It's starting to get scary. So it's something that we're working on, the rest of the industry's working on. We haven't found that new approach, that next big breakthrough yet. So we're looking for it. This is an interesting chart. I showed this chart in my last all-hands meeting. For those computer scientists, this is not a new programming language. This is a periodic table. I'm not sure if they still teach that, but it does kind of look like a programming language with funny acronyms. And I tease my services science research team because they create a lot of acronyms. So you could imagine, but that's an inside joke. You guys wouldn't get it. So this is a periodic table, and what this is showing in the 1980s, the atomic particles or the chemicals or materials that were used to do CMOS processing. Well, in the 1990s, we picked a few more, which helped us, make progress in the 90s. But we got crazy in 2000s. In this century, we really got crazy and decided to try to use all of them almost. There's very few left to use. But you can see we're kind of getting desperate. I mean, you could imagine. And for your hardware guys, I'm sorry, but you could imagine that we're really struggling because now we're picking off every little chemical and material we can find to try to figure this out. There's only a little bit more here to use, and we'll probably try them all. And we actually created some extra ones that didn't exist when we started this. So there's a lot of work required here. This is some of the possibilities, some of the possible replacements for CMOS. Carbon nanotubes holds an interesting prospect, but it's pretty far out, to be honest. Nanowires might be possible if we could figure out how to grow them in a controlled fashion. They want to grow in funny ways, so we haven't quite figured out how to grow them and use them in practical applications yet, but they show some strong promise. Spin transistors is probably the furthest out, although Stuart Parkins, one of the guys in the lab, would say it's closer in. That's where you're using the spin of an electron or a molecule to detect a 1 or 0. Okay, we still got to build detectors, and we still got to do a lot of work there, but it held some promise. We're making some good breakthroughs there. And you can see that molecular transistors hold some promise, although I'm still not sure about that. I mean, you can build them pretty small, but they're not as controllable right now, so there's still a little bit more work required there. But some possibilities. We actually did a little work in using molecules, and this is a tunneling microscope looking at, these are individual atoms. I think it was the carbon dioxide, monoxide atoms on a piece of copper, I think is our substrate. And you can actually, this is a multiplexer and it's quite a bit smaller, hundreds of thousands of times smaller than our present transistor designs or our equivalent circuits to do this. So we demonstrated in the lab. The problem with this is cooled with liquid nitrogen, and it's a very special thing. So it's not something you can mass produce and build a computer out of yet. But it does show that the potential is there to use molecules to actually do computing and build things much, much smaller. For those of you that have iPod Nano, which I have as well, I always like to tell people that at some point, and it actually won't be too long, we'll be able to put in the range of 500 gigabytes into that nano. Interesting prospects, because I'm not sure what you'd do with that once we did, but we can, somebody will find out a use for it, right? Maybe you'll put every picture and video and song and everything else that you'd ever want to store in your lifetime on it, and that would be, of course, losing it's the problem there. I'd be afraid to give my wife one, because I guarantee you somebody else would have it, because she would misplace something that small. But that's okay. I think we'll figure it out. But we're looking at technologies that will actually enable that, and actually that's not too far off. I'm going to have to raise the limit, because it's when I talk to my guys back in the lab, they don't flinch when I say 500 gigabytes in that size. So I'm going to raise it until I make them sweat. So they're not quite sweating yet because they think they know how to do this. But we have some technologies that will actually start to move us to more solid state capabilities at densities that are rivaling hard disk drives, but at access rates that are rivaling our present solid state memories. Maybe not quite to DRAM speeds, but awful darn close. And it will change the way we build systems. We won't build systems the same way once we are able to add that kind of capability into the system hierarchy. And it means we're going to have to program differently too. Right? Once you're able to bring that much storage that close to compute capability, you start to say, okay, well maybe I don't need some of the things that I've gotten used to. I don't know. We put paging in place for multiple reasons. Maybe we don't need pages anymore in our operating environment. Maybe. I don't know. Maybe a flat model would work because we don't have to worry about backing store as much. I don't know. I mean, it opens up some new thinking. This is one of the challenges that you have with very dense solid-state storage is often you can put the bits down denser than you can connect them up to the wires to get it to fan it out so you can access it. We've got some technology now that says, well, you don't have to do that. You can actually access a fairly dense set of bits with very coarse wiring through signaling, through multi-level signaling. And it turns out it actually works. We've actually started building some prototypes to experiment with how much separation of the bits feedback you can get by using multiple levels to access across those bits. And it turns out you can. So we're getting closer to being able to support a mechanism to actually read a very, very highly dense media, and this UMB is one of those examples of that. Well, beyond computer architecture, I've been anxious about this for a long time because we've got a good approach to building processors and systems, but I think that it's time for a rethink of this. And then one of the things that we're going to do is, for example, this year we're going to have an institute at Almaden at the research lab looking at cognitive computing. So is that a model that starts to play in the way we really want to deal with information? Maybe. We're taking smaller steps with this. Cell processor is kind of a deviation from the traditional processor design. It has special processing units that are focused in dealing with information, and we've got multiple of those plus a central processing unit. Fortunately for IBM, right now we are the game processor company. And we have game processors. We're actually the processor in all the top 3 games in the industry: Nintendo, Sony, and Microsoft. So we're playing in what is a growing business, and these cell processors and their derivatives are showing promise in other application spaces. Another area. And we're very proud of this, is that we've actually decided that squeezing all of the compute capability within a chip is not necessarily the best way to build large high-performance machines, mainly because of the cooling challenge. Maybe we should spread it out. Maybe we should use the volumetric density of a room more efficiently and use lots and lots of very simple processors. Maybe that would work. And it turns out it works pretty good, actually. We've just delivered a 300 or so teraflop supercomputer to Lawrence Livermore. We have a 10 to 11 teraflop one sitting in the Albany Research Center. I mean, now that's just why compute's not the problem anymore, right? I mean, you want 2 racks of machine to deliver 10 to 12 teraflops of power. It's not hard anymore, right? And when we deliver the machine to Lawrence Livermore, we replace a machine that filled up a room that's twice the size of what we need. So it's an interesting picture because you take a picture, if you stand down on one side, you can see it just looks like, the computer is all the way on the other end and there's this big open space in between. So we've gotten much better at building machines. Now this doesn't support all types of applications, but it doesn't do so bad. And maybe this is a better way of building machines instead of having, very high performance single chips or SMPs. Maybe if you're focused on data, maybe this allows you to move the computing closer to where the data is, and that would yield a better total aggregate system performance. Maybe there's still some discussion on that. I was told by John Paul this is a controversial chart because not everybody believes data is growing this rapidly. But that's why you sit at a university to talk about controversial things. This is what we would say the growth of business data is. And we actually believe that this is maybe conservative, to be honest, because judging from how companies' hard drive, their storage growth is, this is fairly conservative, and many companies would say it's growing a lot faster than this. All this is meant to say is we've got more information we know what to do with, and there's a lot of hidden opportunity in that information. You just got to get the right kind of analytics in place to actually figure out what you got. And that's one of the problems.
What is offline information?
That's like surveillance videos is offline. Stuff that you have, you can access through other means, as an example, right? Recordings. This recording that they're making, if they're doing it digitally, is offline data. And if they store it somewhere, somebody would have to say, could you bring on such and such that Mark Dean was talking at, and
Where do these numbers come from?
This is research that we've done through discussions with our customers, through data we've gotten from analysts, Gardner, and others. And it's somewhat of a compilation of feedback we've gotten from a variety of sources. So there's no scientific proof on this, but we know that if we talk to our competitors and ourselves about how much storage we're selling to the enterprise industry, which we tend to support, they would say, yes, we're doubling our data store every year. And in fact, we're going to go beyond that. And so this is a good conservative view of what we think our customers are seeing. Now, this doesn't include personal data, right? The data that I create for myself. Although if you look at my email, it's growing more than double. I mean, I create more email. I get more email, and so I'm easily doubling every year. But it's not true for everybody, right? So I'm maybe not representative of that. It just means we need to deal with this. If this is true, we need to deal with it. If we don't, we'll miss, and somebody else will benefit, and that's the key. If it's not true, then we'll worry about something that is not in a problem area. But to be honest, I think this is going to be one of our biggest challenges, and it's lost opportunity. State Farm, for example, is lost opportunity. They're doing this, and they don't know what to do with the data, but they got to save it. The funny thing is they can't throw it away. Once they've collected it, they got to save it. So it's a problem for them. So this leads to how do you find stuff, right? When you've got information that is not necessarily structured, it's, let's say, unstructured, and it's text, and it's video, and it's audio, and it's an interesting mix of stuff. How do you correlate it? How do you associate a video with a book, with audio, with a newscast? You know, how do you make any sense out of it? What are the relationships between them? And that's where it's going to be interesting. We're going to create, and this is another radical statement, but there's a chance we'll create as much metadata as we have data, just to find the data we've got. It doesn't necessarily make a whole lot of sense, and maybe it won't be that bad, but I know we're working hard to create a lot of data that tells us about the data we've got, and we've got to manage that data, which is an interesting paradox, but that's the way it is, and it creates opportunity. And so we're spending a lot of time understanding how to create and manage metadata and what the right standards are, and doing it in an open way. And this chart kind of goes through some of the issues around metadata management, metadata creation. You know, how do you set a standard in place that lives for more than 5 years? Because many of the times it just grows old too quick. We didn't think far enough ahead. And maybe that's impossible, but we've got to do something. Got to do something to help. These are some of the examples, both for structured and unstructured information. There's actually a lot more unstructured information being created, to be honest. And we've got to find a way to be able to deal with that. You know, if you're able to put everything in a nice tabular form, that makes it a little bit easier, and most of our databases are that way. But if you want to really manage content, we've got to rethink how we do that. And these are some of the examples of the types of information that we worry about. There's others, but this is information that at least IBM worries about. So metadata, we used to kind of annotate things by hand. We used to, and we still do, pay people to say, what's this video about? You know, there's people typing about, oh, this video is about such and such. It's got, you know, George Bush and his cabinet in it, and they're talking about this, and, you know, these are the things that came from it, so that now you can associate that video with something that's interesting. You'd like that to happen automatically. You'd like information to be tagged automatically. You don't really want somebody sitting there doing it, because it's not helping, right? You never keep up. So we're looking at that. How can we tag information automatically such that I can find it associated with other things I'm tagging automatically? It's a problem. We're getting better at it. We still need a lot of human intervention for many things, but there's a lot of technology coming to bear that says we'll eventually be able to do this fairly efficiently. Fairly efficient. As we talk to our customers, you know, we've got a lot of customers like this. It's just chaos, right? They've got systems that they've bought over the past 50 to 60 years. In fact, I just ran into, I mean, you guys, I shouldn't tell you this, but I will. The DMV of California still runs, you know, Series 1 application. And again, most of you guys weren't even born when Series 1 was being done. But trust me, it's an old machine. Fortunately, they're running the Series 1 application on a P series, but they're running an emulator. And they're starting to now say, you know, it's not working as like we want it, because we want to add some new capabilities. So it feels funny, you know, that's 30-year-old technology that you're actually getting your tags issued through. So it works, and I guess their performance isn't being measured, because although I wish they would, because it does sometimes take a while to get through their lines and get your licenses and tags and other things. But they're dealing with this as with many of our other customers, insurance companies, finance companies. I mean, it's just chaos. They put in an application. They have a machine. It creates a format for information. As they move forward, they're stuck. Right? They can't move forward. They're stuck. Okay, so we'll put another one in. It does its thing. Now I got another thing I got to deal with, another compatibility point. Right? And all of a sudden they've got 15, 20 of these things. None of them work together, and they don't know how to associate their information across their enterprise. Interesting problem. It's not one that's going to go away, and it's actually getting worse. So it's something we need to help with. I like this chart. This is an interesting chart. This is actually the applications and their interfaces to other applications for our electronic retailer. I mean, this is what their infrastructure looks like. Their application infrastructure looks like this. This is a real thing. And the funny thing about this is if you look up in the upper right-hand corner, that's actually, that little box says page 1 of 2. So this is really just half of their infrastructure, of their application infrastructure. This works, but you don't know quite why or how, to be honest. And they are afraid of this. And we're spending a lot of time trying to help our customers deal with this. You had a question?
Yeah, I mean, these last 2 slides, I think, give me some insight into IBM's success in the services area and what the great need is there. But what I sit here and I don't have any idea of, what's the solution look like? Is it just common platform? Is it throwing a lot of people at it? And what?
No, well, that's what we do now. We throw a lot of people at it.
Yeah.
And I mean, it's fortunate. It's interesting, and I'm going to make a confession here. What caused this is us, the industry, the computer application industry, right? Fortunately, so we created a business for ourselves, right? We made it so darn complicated, nobody can run it but the experts that did it, right? And so we didn't do it on purpose, I hope. At least I don't think we did. I don't know of a conspiracy to create complex computing infrastructure so we can give ourselves, sell services on top. But my wife would think it's a conspiracy, but I don't think that's the case. But it has happened. It has happened. And we can't throw people at it because there's not enough people to deal with this. I mean, the services business will be constrained if we continue down the path we're going with just making it a people business. It's just not sustainable. So we've got to do better, 2 ways. We've got to make things simpler to use. And then that's hard for engineers and computer scientists because the more complicated it is, the better we feel. If I'm the only one that can run it, man, that is the greatest thing ever because it must be good because it can't be run. And our mindset's got to change. We've got to think. My mother's got to be able to run this. It's got to be that brain dead simple, right? All these knobs and controls and special features we put in, most of them never get touched. They sound good. You can make this long list of great features. Most customers could care less. And so we need to get that in our heads, to be honest. So making systems simpler, making applications simpler, and operate anywhere anybody can operate. Just you turn on the power and it runs, and I think that's the other way. Just a minute. And then I think the other thing is that we need to create standards that allow us to move our information more freely. Right now we buy applications, and applications create a standard, create something that I have to keep using. If I now standardize around data formats, let's say, and now that application has to support this standard data format, maybe that's a better approach. JPEG and MPEG, they tend to be that way. You've got to adhere to that or you can't work in my enterprise. Maybe we need to put that around other types of enterprise data and force applications to match that. Or at least that's what I'm starting to tell customers that want to move forward is think about the data you need, the data formats you want, and then force the applications to deal with that. And that way you can, as applications move forward, that data is still the same. Maybe. I mean, these are all, I don't know. These are all hopefully best practices that will start to help. But this is a problem, and it's really not getting any better right away. You had a question?
But don't some of those additional features help sell the product?
Well, we play them up. Yeah, I mean, we advertise them. They sound great, but to get down to it, the customer feels good about it. It's like me buying, 500 horsepower M5, which I'd love to have, but I'm never going to get to that 500 horsepower. Feels good, but when I'm driving down the road, that little Volkswagen Beetle doesn't know I got 500 horsepower and we're going the same speed. So I don't know. So I think taking, and customers are starting to figure this out. They're starting to say, well, I don't know if I need that 500 horsepower or super duper supercomputer thing. When I can buy this little thing and it does the same thing, maybe I don't want that over there. So I think we've got to get smart about it, because you can't fool them all the time. To be honest, you've got to kind of have some practicality behind it. This is another interesting move. I was talking to a peer of mine as we were coming up. People are starting to deal with applications by pulling services off the web, piecing them together, and now that's the way they solve a particular problem. Instead of buying a prepackaged, application that they load, they just start to piece together standard web services, and now they just run their particular operation off of that pieced together set of web services. Pretty cool, right? All standard based, runs well, and it supports their needs. I think that's starting to be the way a lot of enterprise businesses are going. You could argue that's somewhat like software as a service, where you're starting to deliver function over the web, and you buy it as you need it. You don't pay a prepaid up license blah 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 thing. You just buy it as you need it, and as these enhancements are happening, they just flow with you. Or you don't have to say, okay, I need to update XYZ. They just start to work. I think it's a new model. It's an interesting model. Some companies are embracing it. Some of the older software entities aren't, and this is how how our industry moves forward. Right? Is the people that don't have anything to lose, they push on these new things, and the people that have the established business, they do like this. Well, no, I'm not ready to make that move, and I think this is one of those areas. Google's driving hard here. I mean, this is really Google's business, Yahoo's business. I mean, this is where they're pushing hard and have a lot of opportunity. Beyond search and email, right now email sucks, to be honest, for me. I mean, I just can't get through my 200, 300 emails a day, and so I miss out. I'm not working efficiently. So we've created this monster, but we haven't created lots of tools to help me. To help me look smarter, actually. And so we need to deal with that. We need some way to provide better filtering, better insight into the email, so I don't have to read it all or categorize it or something. Some agents that automatically answer it for me. I mean, that'd be cool. I'd like to turn my agent on and it's spitting back stuff, and I have a lot of email I just forward. I just want, just to send it out. I'd love an agent just to send it to, if you get an email like this, send it to such and such, That'd be cool. Pretty soon I wouldn't have to come to work because I just stay at home and turn on my email agents. People think I'm working all the time. They think that now, but, I'd like to get some sleep at night. There's a lot of opportunity here. We've created and are promoting UEMA. There's others. I mean, that's just an example. In fact, this is an open standard that people are starting to rally around, and so we're hoping that that's making some progress. This is my favorite. I talk about this all the time. It's still not design, although we're getting closer. The interesting thing about what I started calling an electronic newspaper, because I hated to open the newspaper on the train or airplane, because I don't know why we build newspapers that way, but they're too big to hold in a seat. And I'd like just a tablet, and so I can page through what I want to read. Well, at the same time, you should be able to download books, magazines, pictures, audio, video. I should be able to download my most favorite movies. I should be able to use it as my cell phone. No, it should be everything. And it should be about the thickness of a simple, small notebook, 8.5 by 11. The challenge with it is not the electronics. Okay, we know how to do that. It's not the software. Okay, we know how to do that. It's not wireless. We know how to do that. The real challenge is the display. because we've yet to design anything that has the contrast and resolution of paper, pen to paper. It's amazing. It's an amazing invention, pen and paper, because we've yet to duplicate it on anything electronic. And that's not exactly true. We built a great big 9 megapixel display that looks pretty good, and you can look at X-rays on it, but you wouldn't want to carry it with you anywhere. I think this is going to happen, and I'd like to get it to a point where you could give these out. So when your third grader went to school, started third grade, wouldn't get any books, wouldn't get anything, any real material. They'd get one of these. They'd be so cheap, the school system would give them away because it'd be cheaper than handing out books and all the other infrastructure that they have to hand out. I think it'd be neat. Yeah, you had a question?
Do you see battery life as an issue for that?
No, by the time we fix the display, the battery will be fixed. If we can fix the display, then I think we'll be able to deal with the battery. Because what we'll do is we'll create a battery that's the same size, same two-dimensional, 8.5 by 11, and we'll just plaster it on the back of the display. And in fact, we'll build the electronics will be built in the display. You don't need separate electronics. So they'll just be popping these things out. I mean, they'll be so darn cheap. And that battery, the key with the battery is once we plaster it, you don't want to replace it. So it's got to take recharge cycles like crazy and last forever. And you got to be able to drop it and throw it around because kids they're not gonna take care of it. So it'll be if anybody can do that, this will be the first, I think, real opportunity to start to replace paper. Because thus far we just created more paper. I mean, my assistant prints out more paper than we printed 10 years ago. We're piling it up, so it's not helping. Question?
I know tablet PCs are out right now. How far do you think tablet PCs are from this kind of technology?
Oh, that's a good question. Again, from the electronics, they're pretty close. Wireless interface is fine. I think the display technology is the key. There may be some other. I think the user interface is not quite right. I'm kind of completely upset about this little advancement we've been able to make in user interface because our present user interfaces suck, to be honest. I mean, we designed them 20 years ago. We haven't really moved forward. We still hit the start button to turn off the machine. What kind of silly... My mother still gets all upset about that. She gets after me. Why didn't you fix this yet? And I told her I can't fix it, but she wants me to fix it. So I think I'd have to say I'm usually more optimistic than reality. 7 to 10 years is probably where we are. I hope I'm surprised. And if anybody knows of a video technology or display technology that would put us closer, that'd be great.
If your vision of that is disposable, which I think is probably accurate, in that case, if it's that cheap, it's going to become disposable. So the kids will get rid of it at the end of the school year. So
you get a new one.
Battery doesn't really have to.
That's fair. But although our landfills will start to, our environmentalist in me might say that way. Oh, that's fair. Okay.
But how about the storage? Because what you're getting is knowledge, and some of it obviously
is
here. But some of it ends up, as you were talking about the explosion of data. Now
right.
Every kid is now accumulating
right.
data that needs to be stored someplace and
right.
that has to be durable.
Right. And like I said, if I can put 500 gigabytes in the iPod Nano, I can squeeze enough storage on this thing to last at least a year. And what we'll do on top of this, the other opportunity is another strange opportunity maybe, which is data banks. Right? I mean, I think it's time for someone to create what we created for money many years ago, which is regular banks. Right? I think it's time for a service for free where people would store their information in a data bank. Video, audio, medical records, all their personal data, grades from many years, all their grade school grades and all their homeworks and testing. I can imagine my mother would love this because she already did this with me and it's piled up in our attic. But if it was all stored digitally, and the key will be is the company that would do this would pay you interest for the right to store that information. Because what you're going to let them do is let researchers leverage that information anonymously, they won't know who you are, to find new trends, businesses, to find new trends that are in the community, in the society. And for that, they're going to pay the bank, and the bank's going to give you a little piece of that, right? And it'll be private. I mean, the key is privacy and security, and the other key is trust. Who are you going to trust with all this information? That's the real one. What existing entities or organizations do you trust that you would let them have your information? Some other countries don't have this problem, right? Because they're already socialized, so the governments or other places already have all this information about them. Here, we don't. We're not too sure about that. I think there is one company I think that's already pretty close to being this by default. So.
You're already getting it. Your Safeway Club card.
Yeah, I know. That's true.
Discount you're getting, a Safeway space.
That's true.
You let them
I agree.
exactly how
Although I have yet to give them insights into my personal discussions outside of what I'm buying them. Now Google, when they're giving you email access, and they'll store your music, and all of a sudden they've got a lot of information on you. That's going to be interesting. I'm not sure if they're a trusted entity just yet. You had a question?
I just more along that same, it's very disturbing these last 2 weeks with the United States government subpoenaing
Yeah.
Google, and
Yeah.
there's going to see more of that when people are there's going to be a backlash when somebody has all of their email records subpoenaed.
Yeah, that's why we need laws to protect that, just like we protect other existing private information that's written down. I mean, it's no different than having it in a file cabinet in a doctor's office, right? You just got to provide some protection. It's just data, right? And so you've got to protect it, just like we protect people today. We've got to figure it out, because I think the economics are going to drive you to have to do this. Small businesses are going to have to buy these, quote, data banks and other computing utilities, because they just can't afford to compete. They've got to do it that way. And so I think the economics are going to drive us in that direction. Question here and then here.
With this technology, like shrinkage and like everything becoming more compact, what thermal mitigation considerations have you guys looked into, considering that everything is getting a lot hotter?
Well, it can't get hotter. I mean, the simple answer is that's not allowed. I mean, I remember when people were complaining about laptops on their I guess they still are, and they do get kind of hot, and so we got to stop that, right? I mean, it's easy when consumers say not acceptable, we jump and say let's fix it, because we can't sell products if they're not happy. This is definitely that way, and I don't think that's going to be a problem, because the compute capability required is not the problem. I mean, we will generate more compute capability than this would need. The display will probably be some organic LED-oriented display. That's not going to, we're going to figure out how to power those, and they'll be very low power. The battery, we'll just have to be able to have a battery technology that's probably made out of plastics. It's probably going to be some kind of advanced plastic battery, to be honest. So the key is to not pull a lot of power. I mean, that's really the key. I mean, I've seen watches go over the years, and now you buy a watch and you just move and it's charged, right? I don't know how they do it, but somehow it works off your body, just the movement. And so maybe we'll get to a point where the compute requirement for this will be such that you don't need a whole lot of battery capabilities. I don't think that's going to be as big of a challenge as some of the other things. Question here?
What would be the incentive for a data bank to store data if the consumer encrypts the data first?
Well, the deal would be, you're right. I mean, the consumer could say, well, I'm going to trick this data bank, and the data bank will call you and say, well, if you're going to store data like that, we just can't give you the same service. You need a special service. So you might have to pay for this special service because your data is special. And that's okay. I mean, that's cool. And then they would get the same service. It's just would be a little different than the standard service as my mother would get, which she wouldn't encrypt. She doesn't encrypt anything now. And she stores it in Gmail and Google. And there's, hopefully Google's not reading her mail or lots of other people's mail, because they'd probably be shocked at some of the things they would read, right? So, but we don't worry about that, right? It's funny how we don't worry about that, right? But that's just as likely as anything else. So it's interesting. It's interesting the things that we just accept and things we don't worry about, or the pessimist of us may worry about them, but so far there's very little encrypted data out there, very little. So I've got just a few more charts on services. And interesting, I probably should have put this first, because we've got a lot of interest in services science, and we've got a lot of interest in what we would say is a new discipline. Similar to the way we needed to establish computer science about 50 years ago, was because IBM and other people in the industry were hiring, well, I know we were hiring musicians at the time. There weren't computer scientists. We were hiring people and training them to be computer scientists. And we decided we needed more computer scientists than we could train, so we needed the universities to kind of push them out. And the universities did. But musicians turned out to be good programmers. Pianists turned out to be some of the best programmers. Actually, physicists turned out to be good programmers as well. For those of you physicists, you should be proud, because for some reason you program and you probably play the cello or something like that too. So that's pretty cool. But now we need people coming out of the universities with a discipline and understanding of how to deliver services to individuals. And right now we train them. We hire computer scientists and train them to be service providers. And we can't do that. We have too many jobs. We were hiring more than 700 people a month just in a part of our services business last year. That's a lot of people. So we need to do this. And I know Berkeley is one of the universities that is embracing this, and we're glad. And actually, our competitors are glad, because they can hire just as well as we can hire from this pool of people. Part of the services science discipline deals with this business optimization. It's very important, because the services science discipline is somewhat of a cross between business science, social science, and computer science, basically. In fact, in the Almaden lab right now, I've got 2 anthropologists working in our services research area. They're business anthropologists, and they help us understand how people work. They do ethnography and business modeling and things that help us understand how people work, how businesses operate. This is some of the new business models that are coming out of that we think have high potential. I talked about software as a service, and I talked a little bit about data banks. A subset would be health record banks, which is probably the most sensitive of data. But you can see there's others, and one that I like to think about is the computational utility, where you don't have equipment in your shop. You access a utility that's available, just like you get power in the phone and gas. You can get compute capability as well. Why have a computer, essentially? I'll skip. This is somewhat an introduction into the services ecosystem. These are some of the companies that are starting to invest and look at some of the new business opportunities in delivering computing services to the industry. And this is the chart. I don't talk as much about global economics and markets. Jim Spohr, my focus person on services science, likes to talk about global economics and markets. I think that's right. I mean, one of the great opportunities is to understand how to do business in a globalized industry. And that's a hard one. It's actually very hard. And we need people that understand that. But right now, I'd be happy if I could get the other 3 circles covered, to be honest, and then we can move into that circle. So in closing, and I'm a little bit over, so I apologize. We're pushing in the area of services, science, management, and engineering. I cut it short, but essentially that's where we're working. And of course, Berkeley is one of the early adopters of this particular discipline. We're very grateful. We're going to continue to work very closely with Berkeley to try to make sure this is a success. I know we're hiring. We really need to make sure that you guys and your sisters and brothers and your siblings are going to take advantage of the opportunities that are here, because there's too much. There's too much innovation required for us not to take advantage of it, and we just need to make sure we've got all the right things in place to make that possible. The right educational system in our K through 12, the right support in our universities, the right funding models. I mean, we just got to get it right. There's just too much at stake. And so, with the opportunities, there are great challenges in the world that we need to stay focused on, try to help figure out, because that's our history. I mean, we've done this for years. I want the United States to kind of keep at this, and it really is something that this room and the people at this university and all the young people in the United States should really take advantage of. If we don't, it'd be just a huge amount of missed opportunity. So that's how I'm going to close. Thank you for your time. I apologize for running over. Sure, I got plenty of time.
There will be refreshments outside, so if you'd like to grab Mark outside with a cookie and a Coke or something,
Sure.
I'm sure he'll hang around for that. But maybe a couple
Any
more
other questions?
general interest questions in here. John?
Yeah, I guess I'm still trying to pin down a little bit the disciplinary core of this, because it's a big landscape that it extends over.
Mm-hmm.
I mean, I actually understood the particular themes you mentioned, except for the business optimization one, which I guess is that business process optimization?
Yes, that's right. That's a business process optimization, right? It's there are others like new business model creation, which I showed as well, but that particular chart was focused on business process optimization. Not just within your business, but B2B as well. So how do I optimize my supply chain management as well?
Maybe another related question is how do you see the interplay between the technology bubble and the social, organizational science and business have that partnership already, especially here.
Right.
Is the technology more sort of mostly a black box? That's one of the things that's in the organizational design, or how do you link the two?
Yeah, no, I would say that the technology bubble is not a black box, because we already know if you just let engineers and computer science build something, it doesn't necessarily match up with the needs of the customer, right? I mean, we try to, and we get very, very close, so I accept that, but we overdo it, to be honest. We design twice as much stuff as we really needed to get to the real problem. And fortunately, I guess, it's kept us in business because we have to go back and do it again because it, keep trying to match it. I think that the stronger understanding we have of how these systems really are going to be used, what types of information you want to do, what are the connections to it, then we will tend to design both hardware and the software to better match the particulars of the business process we want to either model or the types of the ways that business wants to operate. I mean, we actually still design applications in very narrow silos, and to draw across them is very complicated.
I think what you actually sounds like what you're saying is fairly new would be designing those applications macroeconomically.
Correct.
I mean, we design them microeconomically now for specific tasks and pieces of that.
Correct.
Yeah.
And we would say to do that, you may need to componentize pieces of either the business process and the applications that support it. So right now we don't, because we don't componentize it well enough to where I can build new applications from the components, right? And I think we need to come up with a set of standardized components that I can snap together to now create to support the business I want to create. And those standard components hopefully will allow me to move forward So when new standard components come out, they snap in and work by construction. That would be great. If we could have them work by construction. I mean, testing is the biggest problem we've got. I mean, just to know that it's going to work. And we can't put together a system to match our customer system just to test to see. And they always push the limits, to be honest. We have some customers, they always running at the limits. And so it's hard to know that it's going to work 100%. So. Is there a question here?
But just picking up on what you're saying, in old-style operations research, that's what a lot of the goals were, right? To have those units that reconfigured.
Yeah.
I mean, how much of that academic work can be brought to this new?
I think a lot of it. I mean, it just needs to be more broadly embraced, right? Because there's a lot of people that aren't aware of that great work that was done. Maybe we need to read the books, or because I think it's interesting the way technology works, right? A lot of great approaches kind of come back around, and we reuse them with new technology. We bump the technology 20 years forward from when the original approaches were developed. And all of a sudden, oh wow, this is a perfect idea. All right, the ideas may have been way ahead of their time, and we kind of bring them to bear at the right point. So I think that they come to play. I think they actually are going to play well. Question here?
You said product innovation, process innovation, and then business model innovation.
Mm-hmm.
And later you talked about business optimization. And you said that the business optimization is actually the business process optimization.
Right.
So that are a little bit blurring. So I would try to listen a little more about what you have in your mind when you talk about innovation on business model. On business model versus business process. Well, most of the innovation on business models, at least for what we've done so far, and this is maybe very narrow, is the discovery of new business models and being able to model how those business models might work in a given society or business environment. And the hard part is modeling the social aspects of a business model interaction, right? Now you can model business models against known measurable business methods, right? And it's like a supply chain, for example. And you can say, well, will this model work within the supply chain model that I've got, or constraints that I've got? So you can model that. The hard part is to model a business against societal norms, and whether that model survives in a consumer, or in an environment, or an environment that's dominated by a certain religion, or a certain set of norms, quote, that would constrain or enhance the model working. And we're actually looking at that. We're actually looking at, can you model social norms and human frailties, inconsistencies, let me say, because humans are pretty inconsistent, because they can change on a whim, right? And say, well, can I survive what might happen when I put this model in place? I mean, I keep going back to Google. Google's a great example of a new model, right? And they weren't the first to do it, actually. I mean, there are companies that have tried it before, and they fell into it. When they put that, you guys know that, when they put that search engine out there, it was just, grad students having some fun. So, yeah, it's a great tool. But somebody, business guy came along and said, hey, I think we can make some money here. Why don't we put a little ad each time you do this search, and in fact, we'll sell space. And all of a sudden, they're making a lot of money. That was a model that, the newspapers are, is killing them, because it's taking money away from an old staple and putting it in a new environment. But those things happen. So the question is, could we have discovered that model? Could we have created tools that would allow us to experiment with that model, and would have been able to say, yep, that's a good model, we should try that? We imagine that we can, but there's a lot of work required to do that. So, but our supercomputing technology, we're actually starting to bring that to bear, and our scientists believe that we can at least come with some closeness to judging a particular model or not.
You going to cut it off?
Let's thank and
It's fair.
take the rest of the questions in
That's
a little bit
fine.
more informal setting outside. Thank you very much,
Thank
Mark.
you.
Good afternoon. Good talk.
Thank you.
I've asked John Paul if we can get a copy of your slides. If you don't want to give them, then fine, but if you do.
I just have to look.